Hello everyone. Welcome to the demo of our research in Interpretable AI in the application of image classification. Let's look at this image. There is a cat and dog. If we pass this image to a classifier and let's say it classified as cat, now how do we interpret the result of this classification? On the right side, you see a traditional classifier. On the left, the focus of our project, Interpretable AI in image classification. Using various techniques, the results of the image classifier can be visualized to interpret how classifier reached that result. The techniques in this field are broadly classified into perturbation, backpropagation, and activation based. Our research is focused on the activation based, which creates saliency maps. We use three of the latest techniques, Grad-CAM, Grad-CAM++, and Smooth Grad-CAM++, and the last two are the state-of-the-art. Our research is divided into three parts: implementation of state-of-the-art techniques in original classifier and comparing the results in state-of-the-art classifiers like exception and inception V3. Secondly, a novel combination of backpropagation method called integrated gradients with the class activation technique to improve the localization of integrated gradients. And thirdly, a novel technique to improve the saliency map generated by the state-of-the-art class activation techniques to make it more fine-grained, class discriminative, and better human interpretable. To run our application, go to our GitHub link. README has all the relevant information for running our application. Go to Codes. Open any Jupyter notebook that we want to view and run. All the visualizations and results are given in the Jupyter notebook. This is the same for part 1, part 2, and part 3. This is the saliency map generated by three of the class activation techniques on VGG16. These are the implementation on exception and inception V3. If you notice, the coverage of exception and inception is pretty big compared to that of VGG16. Exception gives a result which is more in line with the outline of the object. Even the height difference of the dogs are visible here, whereas inception gives a generalized saliency map, mostly oval in shape. Similar results are observed in other examples as well. Let's see the result of novel combination. This is how the explanation map of integrated gradients looks like. In the first experiment, we did a direct combination and we saw that we improved the localization of explanation map generated by integrated gradients in our experiment. In the indirect combination, we got a result which had better localization compared to that of integrated gradients and larger area compared to that of class activation techniques. The final experiment did not yield better results. Overall, the first two looked better and promising. Now let's see the results of one-of-a-kind novel technique that we devised which outperformed the state-of-the-art technique. Here are the experiments that we performed. We implemented these 4 experiments in 3 class activation techniques using 3 versions of input images in 2 different classifiers. We perturbed the input images to create 3 feature-enhanced versions. We then performed analysis and reached certain conclusions. Input 1 is robust across smaller and larger classifier for experiment 1. Here is the original, state-of-the-art on smaller classifier. This is our on the same. State-of-the-art on larger classifier, our method on the same. Here you see our method is yielding a fine-grained, much better localized and class discriminative result compared to that of the state-of-the-art technique. We saw that input 1 performed the best for all experiments for larger classifier. Original image, reference state-of-the-art, results of the method in experiment 1, experiment 2, and experiment 3. We also saw that for a larger classifier, experiment 3 was successful, especially for input 1 and 3. The saliency map shows that our method is much better interpretable than state-of-the-art technique. Here are some other examples of our work compared to the state-of-the-art technique. To conclude, we were successful at improving the visualization of integrated gradients. Our novel technique opened up completely unique way of visualization, especially when it comes to larger classifiers, where we are able to generate fine-grained class discriminative visualizations which are better interpretable by humans compared to state of the art. With that, we end our demo. Thanks for watching.